So guys, welcome to our channel once again. In today's video on our JAMB Chemistry exam revision series, we have here these 10 JAMB repeated questions on nuclear chemistry to answer. So guys, be sure to stay till the end of this video. Any point here where if you want to answer any question, you can pause this video and try it out on your own. So let's go ahead and start with the first question here. It says, what is emitted during the disintegration of barium Ba nucleus as shown by the equation below? So you've seen the equation here shown here, and we have options A, neutrons, option B, beta particles, option C, gamma rays, option D, alpha particles. So guys, looking at this equation shown here, we have that the subscript reduced by 2, that's from 56 to 54, and then the superscript reduced by 4, that's from 138 to 134. So guys, for this, you're going to have the element here to be helium, because helium actually has a mass number of 4 and an atomic number of 2. So guys, that's 4 above and 2 below. So guys, that's it for this question. And remember, the particle that is similar to helium is the alpha particle. So guys, what was emitted during this disintegration is the alpha particle, and that's option D here. So let's go ahead and consider the next question. Question number 2. So guys, the question says, which of the following is not a major form of radioactivity? We have A, beta particle, B, electric radiation, C, gamma radiation, and D, alpha particle. So guys, the answer to this question will be electric radiation. That's because the major forms of radioactivity will include alpha particle, beta particle, gamma radiation. But guys, we even have positron emission and electron capture. But guys, electric radiation is actually not a form of radioactivity. So that's the answer to this question. Let's consider the next question, question number 3. So here we have an equation of a reaction here. So the question here says, what is the value of X in the nuclear reaction above? So guys, for this, we are going to actually zoom in right here to our workspace and solve this together. So here we have the elements here to give this 86 here, then plus alpha particle. So guys, for something like this here, I already know what will be here, and that's 224. So, but if you really want to solve for this, we know that alpha particle is going to be the same as a helium atom, which is this. So for this, if we want to input this in this equation, we are going to have 226 and 88 here for this, and then this will yield X and 86, then plus 42 for helium. So guys, if you check the subscripts here, you see that 86 is going to be 88 rather is going to be 86 plus 82. So this 82 plus 86 will give you 88. But then here 4 plus what will give you 226. So let's say 4 plus x to give you 226. So in order to find x, you're going to do 226 minus 4. And guys, that's 222. So guys, that's the answer to this question. That's option B here. So we're going to go ahead and wipe this off, and then we'll consider the next question. So guys, the next question here is question number 4 here, and it says, what is the x in the following reaction? So guys, we've seen the reaction here, and let's go ahead and zoom into our workspace here to solve for this. So in this reaction, we have N indicating a mass number of 14 and an atomic number of 7, and then plus X to give us oxygen with an atomic number of 8 and a mass number of 17, then plus a proton. So guys, for this, a proton will, adding a proton to this oxygen will mean that the atomic number will increase as well as the mass number. So they will both increase by 1. So for this, we're going to have 14, 7 for N, then plus X to give 18, since it's 17 plus 1, and then 9 since it's 8 plus 1, and that's for oxygen here. So guys, in order for us to get what the X represents, we're going to consider this for the subscript of S, and then we're going to consider this and this for the superscripts of S. So guys, 9 minus 7 will give us 2 here. So X will be such that we'll have 2 here, and then 18 minus 4 will give us 4 here. So guys, what element has this? That's helium, and that's this. So if this is for helium, it means this is an alpha particle. So guys, the correct answer to this question will be option A here, and that's alpha particle. So we are going to go ahead and wipe this, and then let's consider the next question. What is nuclear fission? We have options A, the process of splitting a heavy atomic nucleus into 2 or more lighter nuclei. B, the process of converting a solid into a gas directly. C, the process of changing a liquid into a solid. D, the process of combining 2 light atomic nuclei to form a heavier nucleus. So guys, the correct answer to this question is option A here, and that's the process of splitting a heavy atomic nucleus into 2 or more light nuclei. So let's consider the next question. That's question number 6 here. So the question says, in the reaction below, X is A. So guys, we have already seen this question before, although here we have different options, but in any case, just know that the alpha particle is similar to the helium atom. So this will be the helium atom or the alpha particle. In whichever way you see this question, guys, you know it's still the same. The helium atom or the alpha particle. So that's it for that question. Let's consider the next question, guys. That's question number 7. It says, how is the decay constant lambda related to the half-life of a radioactive substance? So we have options: A, lambda is equal to 2 over the half-life; B, lambda is equal to the half-life; and then C, lambda is equal to 1 over the half-life; and then D, lambda is equal to the half-life raised to the power of 2. So guys, the answer to this question will be option C here. Actually, the relationship between the decay constant, which is lambda, and the half-life of a radioactive substance is an inverse proportionality. So the decay constant is actually inversely proportional to the half-life of a radioactive substance. So in this case, option C is the correct answer to this question. That's lambda is equal to 1 over T half. So that's it for that question. Let's consider the next question. Question number 8. It says, what is X in the following reaction? So guys, we've already answered this question before now, and I believe you already know the answer to this question already, and that's option D here, alpha particle. So let's look at the next question. In the reaction below, X and Y respectively are. So guys, for us to solve this, we're going to solve this together. We want to know what X and Y are. So we're going to zoom into our workspace first of all, and here we're going to write out this equation. So we have 2, 3, 4 and 90 for this element, and then this will be this for plus a beta particle. So guys, for a beta particle, the mass number will be 0, and then the atomic number will be a -1. So, which means in this case, we're going to have 2, 3, 4, 90, we're going to have X and Y here for this, and then finally let's represent this beta particle with X here. We're going to have the mass number to be 0, and then here to be -1. So guys, for this now, you can now find the subscripts and the superscripts for this element here. So all we need to do is to get the difference between this and this. So 90 minus a -1 will be 90 plus 1, and that's 91 here. So this will be 91 here. So for this and this, we have a 91 here. So let's quickly write this down here. So this will be a 91, and then for the superscripts here, we're going to find the difference between this and this, and that's 234 minus 0. That's your 234. So in this case, X will be 234, and then Y will be 91. So that's option B here, and that's the answer to this question. So we'll go ahead and wipe this off, and then we'll consider the next question, and that's question number 10. So guys, the question here says, which type of nuclear decay involves the conversion of a neutron into a proton and an electron? So guys, the answer to this question will be beta decay. So out of all the options here, option B is the correct answer to this question, and that's because in beta decay, a neutron in the nucleus is converted into a proton and an electron. So the proton remains in the nucleus while the electron, which is the beta particle, is emitted from the nucleus. So the beta decay increases the atomic number by 1 while actually keeping the mass number unchanged. So that's how it works. So that's it for that question, and this is where we'll end this video, guys, for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not a subscriber. If you have any specific question regarding this video, guys, you can drop your question on the comment section below and we'll ensure to give you a response. So guys, we also want to encourage you to join our YouTube channel community by hitting the join button below. And then you gain access to this community where we'll post a lot of updates for you guys on JAMB examination. This will help you even as you prepare for your JAMB examination for the year. So thank you once again for watching this video, and see you on the next one.